Hi everyone, my name is Femi Taiwo and I'm here to talk to you about my experience building for 1,000,000 transactions per hour. And that's my Twitter handle. Please feel free to mention me on Twitter. And a little about me. I'm the CTO at Init. We're a technology consulting company based in Lagos and focused on the enterprise. And we do a lot of projects for the government as well in my country, which is one of the projects that I'm going to talk about today. I am also something called a Google Developer Expert. It's a title given to people who have shown experience, knowledge, and a lot of community work. Fantastic. A lot of community work around specific products. I'm focused on cloud. And there's several different tracks that you can be on. There's web, there's Firebase, there's UX. There are quite a lot of them. You can check them out on developers.google.com/experts. And I'm also a co-organizer for the Google Developers Group in Lagos. And what it means is I get to organize events for developers to come around, learn, do workshops, hackathons, write code, essentially rub minds with developers, designers, and people who are very enthusiastic about technology in general. And I'm also the proud father of 2 kids, a girl who's 5 and a boy who is 1. Lastly, I'm going to take you through what I did, right? I'm not going to say it's perfect, but it worked, and it's a template you could also use for your own projects as well. So I'm talking about this specific event. It's 2015 general elections for the presidency in my country, for which I and my company were responsible for building technology that will be used to do elections on that specific day. And a little bit about that particular event, a one-day event. We had, or we have, 70 million people that are registered. It's a population of about 170 million people in total. Well, 70 million people are registered in that system. And prior to that time, it was a lot of heated debates, discussions around elections, so we're expecting a lot of people to actually participate in the elections. And these elections were going to take place in over 120,000 locations. And those were the spots where our technology would be deployed. And we had over 32 million transactions happen in a little over 24 hours, about 26 hours, from when the election started to the end of the election period. And interestingly, we had 24 days to actually learn about the project, design, develop, deploy, and actually put it out there on the field, 24 days. And there was no opportunity for a pilot. So it was ride or die sort of event, right? So I'd like to talk about the stack that we used for it, right? Thankfully, it was successful. I'm standing here. I'm not in jail, right? And I can talk about it. So it worked. It worked, right? We used CakePHP 2.x. I think it was 2.6 or 2.7. I'm not sure what version exactly, so I let it as 2.x. And we ran a lot of it on Google App Engine. How many of us have heard about Google App Engine or have used it? Has anybody used it? Fantastic. All right. And we also ran a bit on Google Compute Engine. I'll talk about when I list everything on the screen. We ran the database on Cloud SQL, which is MySQL essentially. And we had to populate it with those 70 million records. We also had our analytics sorted using BigQuery. Has anyone here used BigQuery before? Okay, I'm talking to the right audience. Fantastic. And we did a lot of storage as well on Google Data Store. More things that we used, right? So we used the Google Cloud Storage. It's essentially some hard drive you can access really, really fast, really, really replicated across. Amazing. And of course, we use memcached. We used it because we understood it. We don't know if there are any other options we could have used. And we use lots of messaging, or we use queues, message queues, to handle our processing as well. For our monitoring, we use Stackdriver. How many of us know about Stackdriver? No one. All right, so Stackdriver is a monitoring tool, just like PagerDuty, New Relic, quite a few of them actually that are really good out there. For our tests, kept it simple based on the knowledge that we had, based on the time that we had. We used JMeter, and then we wrote a bunch of Python scripts to do serious load tests on our infrastructure. So let's talk about some fundamentals that would sort of ramp up to how we did what we did. Now, the truth is this. It's become easier today, much more than any other time, to actually build and deploy your application. In less than 15 minutes, in 5 minutes really, you can set up a new instance, have PHP installed, have MySQL installed, have your Apache configured, have your code pulled down in there, set up the DNS or the name server settings, and you're up and running pretty quickly. Or maybe you've decided to split it up a little more and have a specific application server and then your database on a different VM. What usually happens next, it's a good kind of problem, can be horrible if you're not prepared for it, is growth or demand or high load, high traffic. And what starts to happen is you start to suffer a number of things. Your customers start to suffer, right? Your quality of service starts to drop. Availability becomes an issue. Consistency of your data becomes another issue. And the performance of your app in terms of speed starts to suffer as well. So if you want to build for millions, there are a couple of things, 4 or 5 things you really need to think about. First is performance. Second is scalability. You need to think about high availability. You need to think about your DevOps and how you're going to keep it really simple, almost pain-free if possible, right? And very, very importantly, how you can keep the costs relatively manageable, optimal, or essentially cheap. So performance. I'm not going to talk about performance because there's quite a lot you can think about in that direction, and that's not the focus of my talk today. I'll go straight into scalability instead. Performance is optimizing your code, make sure it runs fast, making sure you're not doing things the wrong way, make sure you're doing things the right way, you're saving the right direction and things like that, right indexes, lots and lots of things. But I'll focus more on scalability, and it's how you can handle work as it grows, just as it grows, because of how it grows, how much it grows, how you can handle that work in a graceful manner. And we all know the options for scaling, right? You can either scale vertically, which is scale up, or you scale out. And for scaling up, what you simply do is increase your CPU, increase your memory, increase your bandwidth, maybe increase storage on a physical VM, or on a VM, sorry. And usually, if you're planning to handle millions, you quickly realize that there are limits to how far you can actually scale on a single big machine, or maybe 2 big machines, one for the application and one for your database. And that physical limit, for example, is 512 gig, as far as I understand. And you realize that if you're going to keep scaling up and scaling down as traffic comes up, imagine, for example, you're doing a payroll system, and you know that at the end of the month is when payroll is crunched. So maybe on the 26th or 25th, you scale up your server, and then when everyone is done by the 2nd or thereabouts, you scale down again. In most cases, if you're doing that, the few seconds where that scaling happens, you probably lose some availability, and your customers may not be able to access your service in that time. And then you think about the money you spend, right? Just to keep a big machine running. It's a lot. And you also think about the DevOps operation that needs to happen. Someone needs to monitor that process, make sure that everything is working fine as expected. And there's the alternative, which is horizontal scaling or scaling out. Simply by adding more machines into the cluster of your application, what runs your application, or reducing it when the demand goes down. And with that, there are also challenges. We've all heard about challenges with, we may have heard about challenges with horizontal scaling, the CAP theorem about consistency, availability, and partition tolerance, how it's a little difficult to manage all three at the same time. How many of us know about the CAP theorem? Okay. So it's essentially stating that it's difficult to ensure that you can be consistent, always available, and you are able to stay on even when some part of your infrastructure fails. It's a little hard to actually have all three working perfectly together. That's what CAP theorem is about. And for a freshman, I call it freshman, that's a newbie, someone who hasn't done this before, or someone who's just trying out for the first time. The usual way we scale is, let's just break up our application server away from our database server. Let's add more application servers as the load is increasing, and then you experience bottlenecks with your database. So let's set up replication, and then you experience problems with managing the replication, the limits on the writes, on the reads. There are all sorts of challenges you'd experience as you go along them. And with experience, with knowledge, with direction, there are a couple of things you do differently, right? Which is what I'm talking about today. How you would scale out much better. And it starts with the design of your application itself. If you can get that part right, scaling out to handle millions, several millions, becomes an easier work. It's not easy, but it becomes a much easier work. And these are things that you would need to do. Parallelization is simply running multiple processes at the same time. Asynchronous is deliver an answer straight to the person, but do a lot of processing in the background, which is respond first, work later. And we'll talk about that a little further down in the slides. And idempotency is, regardless of where it goes, you will get the same results. If someone says, what's the current list of articles, for example, on a newspaper website, he gets the same list regardless of which server gets that load. Shared nothing means you're not really storing anything on the node running your application other than your code. Everything is stored elsewhere that can be accessed by all of them. Partition data is storing data for specific things or specific users in specific areas, making it easier for your user data to be accessible for those users rather than having everything in one single place. Fault tolerance is when there's a problem, will your application still work? Will your user be able to still use your application successfully, even if it's not to deliver exactly what he wanted originally? And lastly is autonomous, which is things should happen almost automatically without you having to do anything about it. And then there's availability, right? It's the capability or capacity of your system to be operational when needed. And it's something we hear about 99.99% or 5 nines or 6 9% availability on your application that is demanded by our users as we go along. For us, this was very, very important because all we had was a 24-hour window where the results will be pushed out, and we needed to be able to handle it regardless of how often or how much was being pushed. And how many of us, just curious, how many of us sometimes press Control S or Command S to save a couple of times at once? You just to be sure it's saved, right? And we were sure that was going to happen as well. So we're expecting the same transactions to be sent over and over again from the field. And here are the signs of poor availability that you can easily notice when you're using any application or even within your own application. You start to see unexpected behaviors, and you start seeing errors and lots of errors, strange errors you can explain in your logs. If you've run an e-commerce site, you know that part of what can happen is a race condition where two people order for the same item at the same time and there's just one of it in stock and everything just goes bonkers, right? or an experience where it takes a really long time for your user to experience or to get what he wants out of your system, or the system times out completely, or you are forced to restart on a daily basis, or more often than that. And here are the usual suspects for poor availability. You run out of memory, or storage, or essentially just run out of CPU power. The errors I've seen before that I never thought I would ever see, like unable to allocate memory. And you see yourself experiencing a lot of poor availability when you have a lot of moving parts that you don't really have control of, or there are no contracts between the different moving parts of your system. So things sometimes get changed and it causes problems. And if you're depending on third-party services like most of us do, for your email, for push notifications, for SMS services, there are dependencies that you don't really have control over, and this can actually affect your experience. You can have a user sign up and not get a welcome email, for example, where you need to click on confirm link to access his account. Or technical debt from building things in a hurry that were not well thought through, or upgrades that you needed to run without being prepared, without having a maintenance window, and things like that. So high availability is the exact opposite of that, right? How do we essentially ensure that we have high availability in our applications? How do we ensure the application is always up, always accessible, always responding, and providing the kind of performance we're expecting to our users? And it's a journey. It's a journey, continuous journey really, based on traffic that you experience. And the first and most fundamental step in the journey to high availability is to design and develop your application very deliberately to provide high availability. And I'll talk about that a little further down. And second part is expect things to fail. Build defensively, right? Write your code with that in mind. That really helps. Because what it does for you is helps you catch or trap all sorts of errors that you will experience or may never experience. But if you build defensively, what it does for you is it protects you against the most common kind of errors. And you need to identify your risks well ahead of time and be able to deal with them. And the risks, there are many of them, right? I've listed a few of them as well, which is applications can crash, you can have a corruption, how do you deal with that? How do we have a backup plan? Do we have a replication server set up for at least read-only access in case the main database crashes? What if your availability zone goes down, for example? Do you store all your application in one single availability zone? Or you have storage problems. How many of us have run out of space before on our hard drive running an application? Look, I have as well, right? Or there's connectivity issues. And part of the way of ensuring you have high availability is to monitor every single thing that goes through your system. The health of your server, how much CPU usage is actually going on, how long are processes running for, how long are requests actually going on for, what's happening with them, how is it performing, how much memory is being used up, how much is being left over, how long are processes really taking, and what's the trend? Is there a pattern to what's really going on? Your logs, your monitoring tools can tell you this. It's hard to tell by looking at the logs yourself, but there are plenty of tools to tell you about that. And what's the latency like between your application server and your database server? Have you ever made the mistake of putting them in two separate zones? And there are plenty of tools to help you do the monitoring. There's Stackdriver, I mentioned that earlier. There's New Relic. There's Datadog. How many of us have heard about Datadog? They're amazing. They're fantastic. And there's PagerDuty. It's amazing as well. It allows you sort of set up alerts and notify your engineering team when there's something going on and set up like schedule if you have like a big engineering team. And what you would also need to do in this journey to high availability is have a plan. When there's a problem, when there's an alert, what are the steps to take? When there's an issue, where do you begin to diagnose the issue? When there is an unexpected problem, what are the steps? Don't wait until there's an issue to have prepared that email to say there's a problem. Don't wait until there's an issue to be able to roll back or to be able to switch to a different database server. And you would also need to be able to automate all your operations. And I'm talking about, for example, the testing that Viraj talked about. Automate how you roll out your application. Don't do rsync into your server or log into your server and do git clone or git pull, git, right? How do you manage your configuration? Do you do any sort of configuration management? Do you do that? And it's something you need to do. And how do you roll back when there's a problem? So let's talk about design and develop deliberately. Many of us have heard about microservices. How many of us currently actively develop using microservices approach right now? Okay, fantastic. And I'm curious, if you don't do microservices, is there a reason you'd like to share? Do you think it's, so I'll just give examples. Do you think it's complicated? All right, I think so too anyway. All right, do you think it's too much trouble? All right, fantastic. Yeah, so getting over that hump is all you need to do. Just getting over, you know what, this thing is hard. I'm just going to try and do it. Just like Viraj's explanation about doing tests, writing TDD or doing TDD, right? If you can get over that hump, you'll be a happier person all the way through. As from experience, we have built a system that currently was built with a monolithic architecture, which is everything is coupled into one single gigantic unit. And scaling on it was a nightmare, still a nightmare, because we're trying to switch away from it, right? And that's because we're getting a huge amount of traffic on that platform. And unfortunately for us, because it's so tightly interwoven, there's really just one module or one area of the application that is enjoying so much traffic. But the rest of it, the other 20 controllers in this application are not really doing much in terms of scale of the application or traffic to the application. But every time we want to make any sort of updates or pushes, we have to re-upload the entire application again. It's been difficult actually scaling that particular application because everything is too interwoven. And that's the challenge that I usually get with monolithic applications. And the second part of what the problem we experience is it's harder to actually focus on one single or have a single team focused on one specific part of the application. Part of the benefits you get with microservices, I'll talk about it in a slide going forward. And the challenges, as I mentioned, with monolithic applications or monolithic architecture is the high coupling nature of the application itself. And if you do continuous deployment, it's way harder than if you were to do it with microservices. And I'll explain why. I'll skip forward, skip back. Okay, yes. And the truth is, if you're doing with monolithic sort of structure, you are forced in a way to stick with one single technology all the way. So if you're using a specific language or platform, you sort of have to keep it that way all the way through, forever, unless you want to switch completely away from it or move to microservices. And when you're trying to scale, it becomes an issue because it's highly coupled together. With microservices, on the other hand, what it does is it allows you to create relatively independent components in your application. So if you wanted, for example, you can have the user account management part of it done in PHP. You can have the checkout process for an e-commerce site, for example, done up with Node. You can have the shipping service part of the application done up in a different language. And we did something similar with the system that we built. And I'll show you this, how we broke it up into different services. And what it did for us is we had different kinds of engineers in the company with different levels of skill, and they could all contribute to the development of the application. It wasn't a case of, well, we have 2 PHP guys that are free, this will have to be PHP, right? It was, you have 2 PHP guys, you had 1 Node guy, you had 1 Python guy, you had 1 Java guy. You know what? Everybody can essentially build your application. The important thing about doing this is to have a defined contract or a defined set of responsibilities that each of the components will have or will respond to. So it's just like your APIs. Think about it as APIs. If you're connecting to an API, there really isn't any concern about whether the thing generating the API is written in any language. There's no concern, right? It's all just, you push stuff to it and it responds to you. There's really no concern whether it was written in .NET, in PHP, in JavaScript, in Java, in Python, in Go, in Health, or any language at all. And what it does is it makes it essentially very, very easy to scale, to deploy, to test, to maintain, and to improve. Because what it means is that small or that single component can be easily changed. The contract remains the same, but improvements can be made everywhere else about it. And the key criteria for determining how you should build a microservices, or to call something a microservice, is that it would have an independent code base, which essentially means that every part of your application, the services part of it, would have its own code base and would have its own independent data. I know there are challenges with that. I'll talk about it. There's a slide specifically to address that issue. And it would have a well-defined role in terms of what services it provides or what services it can consume and how it does it. And it's owned by someone or a team of developers or a unit in your company. And what it means is that that unit is responsible for it and take full ownership of it. The truth is this: the bigger your application gets, the harder it is for a sense of ownership to actually be there. If you have 20, 30 controllers, let's assume you have that, right? What you have is a very complex system, and sense of ownership is a little hard. I mean, I have 20 or so engineers in my company, right? The applications where one person was essentially responsible for the whole thing, when switching around developers, the sense of ownership is a little harder to establish than if someone was responsible for example, the SMS sending part of it, right? Or there's a unit responsible for that. There's much more passion and much more energy coming out to make sure that that part of the application really goes up. And to break something into a microservice, it has to be defined by a requirement, a business requirement. And of course, it has to be a reasonable size and role. You don't have microservices for every single thing. I'll show you how to break it up a slide later. Yes, and this is the slide. So how do you break up your application if you're planning to build your application into a microservice? You can either do that by business capability or by domain-driven design. Sorry, this sounds strange. Okay. I'm not sure what I typed there. Okay. Or it's domain-driven. I believe that's what I wanted to say, right? I guess I'll remember what it is. I can't remember right now. Okay. Or you can decompose it by a verb or the use. So you can, for an e-commerce platform, for example, you can decompose it by saying this is a microservice that is going to handle the shipping, the order, the SMS, the payment part of the application, or by nouns and resources. And the core benefit for doing this is you can easily scale any part of the application. So if I have an e-commerce site, for example, I can easily scale the catalog part of it because that is where a lot of people spend their time, browsing through the catalog. I do not have to worry about the rest of it because the core volume is on my catalog. Yes, a few of them I will convert and eventually get to buy something on my site. But by having it in a microservice format, the catalog service can run, for example, on multiple servers, while the payment runs on fewer servers, while the shipping runs on fewer servers, and that sort of arrangement, which is fantastic. And for example, if you've tried this before, you could try this, loading your entire database into memory. Works amazingly, right? Works amazingly. So you could do that, for example, for a service that gets a lot of traffic, and figure out how you're going to sync to the main database itself. And I mentioned before that having an engineering team with different skills and different languages, if you're going to build anything and you're using a microservice approach, your entire engineering team can actually contribute to it simply because you're using microservices format, and they can build whatever needs to be built. At any point in time, you can take out a service, not take it out, you can replace a service completely with a different language if you want, but the whole system still functions as expected because there was a defined contract. This is what you take, this is what you send back, this is what you receive, this is what you work, or this is how you work. These are the responses I'm expecting from you, these are the requests I'm expecting to get from you, which is amazing. And if you have part of your application that is compute intensive, then what it does for you is you can have a machine that has high CPU and low memory, or high memory, low CPU, or any sort of arrangement that you have. And what it does is allows you to sort of specialize your machines based on the actual service running on it. And of course, encourages continuous deployment, because rapid improvements and changes can happen, and you can improve that service as often as you want. But it's not utopia. There are challenges with microservices, plenty of them, right? Requires that you have strong interfaces, and this is why I mentioned a strong contractual role earlier on, a strong contract defining how your microservice or that service will respond or request information or change things. And if you're doing microservices, most likely they're running on 2 separate or 3 separate VMs in the same data center, on the same physical machine, or in the same zone. And what usually happens is you get a lot of transmissions on the network, ingress or egress, depends on how you set it up. And you have to sort of have specific machines that have been configured to handle specific services, which can be a problem depending on the kind of infrastructure that you have in place. And it can create a problem for your DevOps team, because now they have to get logs from multiple servers or from multiple services. You have to monitor more machines or more services than normal. And you have to have a plan, an automated plan for your deployment of your application, which can be hassle to set up if it's your first time. But once you do it, it becomes rather easy. And thankfully, we've had conversations about containers and Kubernetes yesterday and Docker yesterday that we can actually use to sort of help us with this process. And for the elections, so what did we do? How did we break it up? We broke it up into these services that you have listed on the screen. We had a service that handled the configuration of all the devices we had on the field. We had 120,000 devices. Actually, they're physically on the field, being used to accredit people, check on the voters register, transmit the information on election day to our backends. And these devices needed to be configured. Some of them were already configured, some were not configured, so configuration was going to happen that morning. And because we had no idea of how many were actually configured or were going to be configured on that morning, we had to create a different service specifically responsible for that, so that if, for example, we get overwhelmed, it doesn't affect the rest of the services. We can still run the transmission, verification, reporting, user account, updates, and storage service without, even if that one was down. Same thing for transmission, sending of the voters' information, where we got 32 million of such transmissions unique actually. We got much more than that. We got 48 million to be precise. We had a verification service, which essentially was someone places his hand on the fingerprint reader, information is scanned, sends to us, we verify it exists, it doesn't exist, we send it back to the device. We had a reporting service. Stakeholders wanted to know what was going on, right? What's happening on the field, real-time information. They wanted to generate reports. Let's see what's going on. And we needed to make sure that they could access the report regardless of the kind of traffic that we're experiencing. Don't forget that we had no insight into how this was going to run. All we knew was there was just one day, Judgment Day, that everything was going to happen, right? So we just sort of built everything out in a way that would be very easy for us to recover if there's a problem. Dealing with one service being down is great. Dealing with the application being down is horrible. For an e-commerce platform, for example, I got this for a slide from a friend, Celeste Nomin, who worked at an e-commerce platform, one of the biggest in Africa that Prosper mentioned yesterday, Conga. And what they did was to have a microservices approach. And they're dealing with thousands of orders, I don't know how often, but they're doing a lot of orders in the country. And I think for one of their days, they had a day called Black Friday, just like you have here in the US. What? Yes, correct. It was called Yakata, right? And it's like a Black Friday that you have here in the US. And they did over ₦1 billion in transactions on that day. ₦1 billion is about divided by 300 is this is interesting. Okay, 3 million. All right, I think, yeah, $3 million, right, in transactions in one single day. And what they did was to split up the application into different microservices to handle all of that traffic. And it didn't go down one bit. Handled it very well. Response time was amazing. Now, a key component in what we used to protect ourselves from judgment was to use message queues for everything, right? So if a transmission comes in, we don't process it, we just say, okay, yes, thank you. We take it, right? And we save it. Data was encrypted, so we didn't even bother checking if it was encrypted correctly. We didn't check the hash there. We just said, okay, thank you, I've gotten it, right? I'll let you know about it later if I succeeded or not. And then we put that into a queue. And I think maybe I'll try and show us an example of how the queuing works, if I have time. And as I mentioned, everything was pushed to the queue. So even the report generation process was pushed to a queue. After the entire process, we create a new object on the queue and say, you know what, you need to generate a report that shows the most recent statistics in the system. How many people have shown up? Put that into a queue. And then cache the results. And then show it to the user when it comes there. So we understood what we felt was important. The stakeholders wanted to know what was going on in the field in real time. We give them near real time. Near real time was 5 minutes at most, rather than trying to generate the report on the fly every single time. And the queues really helped us with that. And for anyone who hasn't really worked with queues using our RabbitMQ or any of the other queuing systems, a message queue is a queue of messages sent between applications. So we had it set up between our different services, and each one of them had a responsibility for finding out or for dealing with any messages on the queue for that specific service. So for example, if someone signs up on your website, you shouldn't do in that method called the register method or user add, this email send, right? You shouldn't do it there. And you shouldn't go store it in your database and have a cron job to run and go through it. You shouldn't. Put it in a queue. For many different reasons. First is you can experience problems with your cron jobs when you have a lot of it happening, and let's assume you still have a cron job to run every minute. That can be hard to manage. How do you manage retries, for example? You have to manually manage that. But with the queuing system, just add it to the queue, and then have an email service that says, hey, is there any message in the queue for me to send out? Sees it, sends it out. If it fails, it retries later. If it fails, it retries later. You can set up all sorts of configurations to notify you when it fails, for example, how often you should send things out, and stuff like that. For those of us who use services like Twilio or any sort of service, third-party service, where you have enforced limits on how many requests, for example, you can make to their API in a second or in a minute or in an hour, right? You can set up your queuing system to enforce a rate so that it stays below the threshold that has been set. And how it simply works is you add something to the queue, and then a receiving application takes it up, handles it, updates the message, or creates a new message in the queue that, hey, I've sent out the email sent. And why it's important to use queues is if I had that method where I did this email send in my controller that essentially happened as part of my registration process after this user create, this user save, and then below it I have this email send, I have that. If it fails, what do? Do you trust your email service that it will never fail? Could there be, for example, a problem with the email account and then email doesn't go out? How do you find out those you've sent emails to or those you haven't sent emails to? And that's where redundancy via persistence comes in. If you get loads of traffic all of a sudden, let's assume you get mentioned on Hacker News or you get mentioned on TechCrunch or our own Tech Cabal, for example, right? When you get a lot of traffic on your platform, how do you handle it? And the other thing it does for you is asynchronous messaging into your application such that you can respond right away to users, even though there's a long-running process that needs to happen. For example, crunching the payroll. And it gives you the space and flexibility to decouple your application into microservices. Really, you can't move into a microservice approach without using a queuing system. They really, really go hand in hand. They really go hand in hand. And I mentioned the race condition earlier on. You have one item in stock, and two people are ordering for it at the same time. And one person needs to complete that order first. Otherwise, what you have is two orders completed and only one in stock, actually. And you now have to call your customer and tell him. Now, imagine if you have 100 orders happening every single minute. How are you going to manage that process? And what it does for you as well is to make sure that it's easy for you to scale. And you can break a big task, like what we had to do. Receive the transmission, decrypt it, open it up, check that the hash was correct, check the data was sent correctly, has it been sent before, update the report. So many different things in there to happen. But we're able to break it up simply because we're using a messaging queue or a message queue, and it enabled us to even be able to pause any single part of it to be able to do other things like fix a problem on the fly. And you can monitor your queues very easily. I think I'll show us an example. I see I have good minutes left. And caching. Caching is something you need to think deliberately about as well. What is it that I need to cache? What changes? How often does it change? What is requested the most? If you're running, for example, a site that gets a lot of traffic and you're not specifically caching the data that doesn't change the most, you're probably doing it a little wrong. And I thought to mention some other non-application things that you need to think about. What if the server rack running your application fails? What's your plan for that? It can happen. How many of us had problems when it was SES that went down in February? S3, sorry. Right, S3 went down in February. A lot of people had issues. And a lot of services were negatively impacted by that, right? Thankfully, with things like Docker, Kubernetes, or containerized sort of approach to doing your applications, you can actually set up your applications like distributed across different places. And if this one ever goes down, for a few seconds, some users might suffer, but immediately they're redirected to a different location where the service is still readily available and readily accessible. What if there's a problem with the router running your service? And this happens. I get emails from different hosting services once in a while complaining about this delays or high latency and things like that, which my consumers or customers are not really concerned about. They're really concerned about the experience that they have. All that issue about, oh, it's my host, it's not really their concern. And what if you happen to deploy your application or be in a place where the entire country is disconnected from the internet? And that happens, at least in Africa, where we had, for example, a place that was off the internet for a couple of months. Essential part, know thyself, run tests. And by thyself, I meant your application, right? Because it's part of the output. And the only way to tell if your application is ready for the kind of load you're expecting, or ready for all sort of load, actually, is to test. And there are plenty of tools to do that test. These are different tools that at one time or the other I've played with, but specifically, we used JMeter and Apache Bench because that's what we understood how to use. There really wasn't much time for us to experiment. Let's try different things. Let's learn, right? We got 24 days to do all of this. And Busy Machine Guns is an amazing testing framework for Amazon. And it would allow you to test your application across different availability zones, huge amount of load on your servers. Be sure to turn it off when you're done so you don't run a huge bill, right? Theorem is amazing. And all of these guys allow you create not just a simple URL test, but you can actually define a process, which is create a user, log in with the user, extract the cookies from that header, use the cookies that are extracted to create a new article, post a comment, do this. You can actually do amazing things with all these guys. And JMeter I use pretty well. I don't think it gets enough mention. It's amazing. And so much more that I've mentioned on the screen there. I'm happy to share my slides. And once again, these are the different things we use to build our software, platform, application, right? And for all of this, we use the Google Cloud Platform. And Google Cloud Platform is the cloud computing service by Google. And it offers you the same sort of hosting infrastructure that runs the entire Google products or services. And they have a couple of offerings that are very, very interesting that you should check out. There's a container engine, which allows you to set up a plan or a configuration, a setting that automatically scales up or scales down your application based on traffic, based on volume, based on any sort of metric that you set up. So once you set up your application in that, what it will do for you, it will monitor how much CPU and how much memory is being used up, how long the processes are actually taking. And based on that, you would say, you know what, if it exceeds 80% for more than 5 seconds, or for more than 2 minutes, or 3 minutes, please spin up more servers so that my other users can access the service without feeling any sort of impact of any single user. I've experienced it such that one user on my application was trying to generate bills for 100,000 properties, and it essentially held up the server until until it was done, right? In that kind of scenario, what would have happened was the container engine would automatically spawn up new nodes so that every other person would be able to access the service, even though he's holding up one different node on his own side. And there's also Cloud Spanner. Sorry, that's my OK Google. There's also Cloud Spanner, and it's the first managed relational database that offers consistency and horizontal scalability across your database, which is something that was very, very difficult before now. But in March this year, Google has released this product, and it's an amazing tool that will allow you to scale like never before. Remember I mentioned the CAPS theorem about consistency, availability, and fault tolerance when there's partial loss? This addresses that specific thing. So what it means is, if, for example, you were limited earlier on to, say, 25,000 queries per minute, or sorry, per second, or 25,000 writes per second on your MySQL, using Cloud Spanner, what you could do essentially is increase that to 2 million if you wanted, simply by multiplying the nodes by 10. And it will be consistent across. If you've ever tried to do replication and you've had multiple masters, you know, it can be a pain. Cloud Spanner specifically addresses this particular issue. There's also App Engine, which is a platform as a service. There are similar services across different providers. I'll talk about Amazon in a slide or two. And what it does is automatic scaling for you. I'll see if I can show you an example of that. And there's Compute Engine, which is essentially the same as a regular VM, but with many different options and discounts that can help you out, especially when you're doing a lot of processing, you have a lot of nodes. And if you like to try out Google Cloud Infrastructure, any of the products, there's $300 worth of credits, free for anyone who wants to try it out, simply by going to that URL. And there are plenty of courses available to take you through any of the things I've talked about, whether it's App Engine, Compute Engine, containers, Kubernetes, machine learning, and quite a lot more if you go to this URL and you allow you to set up VMs and try out things at no cost whatsoever to you. And last month was Google I/O, and there are lots of sessions, over 150 different sessions across doing different things. About 25 or so of them are on cloud infrastructure. You can check out on cloud, they can check out. And we also have Amazon, for those of us that use Amazon. They have they have two actually, platform as a service things that you could use. There's Elastic Beanstalk, which provides auto scaling to your application and provides health monitoring for you. So if you get lots of traffic on your application, it monitors it and automatically scales it for you. There's Lambda, which is more recent, which provides a similar sort of option, and it allows you write small snippets or larger snippets of code that can actually act as a microservice, for example. This Lambda can help you with having a microservice or having microservices. More things I thought I should mention to think about. I think Mark mentioned this yesterday about splitting your code and data. Really don't put both of them on the same machine again. If you still do that, please don't. You have to think about how you're going to manage the state. If you're having multiple application servers, where's the session variable, for example, stored? What if this person signs in here but then ends up on this other page? How are you going to handle it? Or on this other server? How many of us have read up or heard about HTTP2? Okay, fantastic. So HTTP2 is a new standard, well, not so new, but what it essentially does is, you know the way requests generally happen right now. If you go to www.femi.com, not my website, right? The browser downloads that page. Then it parses the page and says, okay, where's the header? Any links? No, I don't mean like links. I mean like any style sheets, any images, any JavaScripts on the page. And then it makes a fresh request to the URL for that specific JavaScript or that specific image, that specific CSS. What HTTP2 push support? One of the things about HTTP2 is push support. What it provides is, in that response to the browser about the page, the server automatically pushes those elements alongside the HTML that it's sending. So it's sending out the CSS, sending out the images, sending out everything to the it can send out everything to the user's browser. So immediately, there's no need to make further requests, because those requests actually take a few seconds to go pull and show and bring it down. And that would essentially really help reduce the amount of the latency or how long it takes to paint your page. And of course, CDNs. We all know content delivery networks and how they can really help us. And graceful backups. Essentially, what it means is if there's a problem with a service that you're using, retry. If it doesn't work immediately, give it a few seconds, retry again. If it doesn't work, give it another 25 seconds, like exponential backup. And think about alternate services to what you use. So what if I'm suddenly having a problem with a particular service provider? How do I switch? Or can I just already actually have a switch in my system already that I can easily just turn on or turn off? Here are things to remember from my talk. For you to scale to handle millions, even per minute if you wanted, it starts with the design. You really have to think about it. If you've already built the app, probably want to rebuild specific sections of it. Otherwise, there's a limit to how much scaling you'll be able to do with it. Expect things to fail, because they will. Especially when you have a huge amount of traffic coming to you. Conditions that were never possible before will suddenly happen. Expect things to fail. Identify what your risks are, especially when you depend on third service providers, especially when you know you may get a mention on Hacker News, for example, especially if you know that you are an item of interest to hackers. Identify them and deal with them. Monitor everything that happens. Actually monitor it. Don't just have stuff set up. Don't have logs and just say when there's a problem, then go and look at the logs. Actually have a process for monitoring what's going on. Provide a predefined list of steps for handling when there are issues, or when it's time to diagnose, or when there's a problem. And lastly, automate your operations. And I've included a slide with additional things to read about Spanner, the CAP Theorem, HTTP server push, bees with guns, and a lot about microservices as well. And one more tool you could try out to try out your service or your application is Core Loader. Thank you very much. Any question? I have exactly 1 minute, 30 seconds.
How much did you pay about the services?
How much?
How much did you pay for the service, about the infrastructure, about the Google App Engine or some group compute?
Everything cost me about $400. $400.
400 US dollars.
Yes. Everything cost me $400 for that month.
Yeah.
And then since then it's cost me, I'm still having the data, everything on there, right? But there's no traffic, so my scale, everything is on like maybe $50, $60 a month.
Yeah. And the election is a half day.
What?
The election is a half day or a full day or
An entire day, yes.
half day?
1 day.
1 day.
1 day, yes.
A morning is 8 and evening night 8.
No, starts in the morning, ends when the last person votes. So when it ends is not really really clear, but usually it takes like up to 24 hours. So you can start 8 in the morning, but
Yes.
run until the next day at 8, because votes are still being cast.
Thank you.
You're welcome.
There's a question from Jeremy Harris on Slack.
Okay.
You talked about fault tolerance and allowing other parts of the application to run if a single service fails. How do you handle the message queue itself failing?
Interesting question.
Savant's answer is crying.
Yes, I agree. I agree. I agree. I don't know. Okay, so I just realized that that's actually a weak point in what we have, because it could fail.
Redundant? Do you have more than one? Yeah. Depends on the queue. You have more than one server?
Oh, you mean the queuing? Oh, yes, you do have to have more than one server. Sorry, you do have more than one server, right? if you're using Google App Engine, Google handles that for you. You don't have to think about it, right? So we never had to think about it. We never had to.
It was already redundant.
Yeah, it was already redundant.
There you go. Okay.
Yeah. Yeah. Any more questions?
Did you have a one queue with multiple workers or multiple queues? Here.
Oh, okay. Fantastic question. We had multiple queues.
Okay.
So the requests. So when a transmission comes in, right? It's a transmission of information. We need to know what is inside and decrypt it and all of that, right? That needs to be processed really fast. And then there's a queue to generate statistics, right? So every single time a transmission comes in, we need to generate statistics, but we don't generate it for 5 minutes, right? So I have a queue. It's not a cron job, a queue that the rate is set to 1 in 5 minutes. So no matter how many objects are on that queue, only 1 in 5 minutes will get executed. So I don't generate the statistics more than once in 5 minutes. So there's that on one side. So for each of the queues, I had different rates specific to the use case or specific to the service. Yes.
But per queue, you just had one worker or also multiple?
I left in this specific example, I left that to Google to handle.
Okay.
Right. So App Engine, I was hoping to run that, but it might take me a few seconds to set up. But you know what? While I'll show you any other example. Any other questions? Sorry, I'll just run this so we'll see. So this is Apache Bench, and what I'm doing is I have a service that is simulating the sending out of SMSs. This first part, what it does is it generates a random SMS message and saves it to a database. And then what happens next is the information needs to be sent out. And what I've just done now is to run this, and look, I'm seeing that I'm able to handle 124 requests per second. But in the background, there's a queue, console, scale bank, yeah. So in the background, do not fail me now, there is a queue. Yeah, task queue. Fantastic. So, it's done already. Wow, too fast. Okay, so I had this queue called outgoing SMS that when these things happened, it essentially put it on the queue here. And as the queue was being processed, based on the load, what was happening was new instances were spun up to deal with it, right? And I could set the limit if I wanted to manage my costs, or I wanted to set the limit. You get, so that's essentially the answer to the question. Any other questions?
One question here.
Sure.
In that judgment day, did anything went wrong? And how did you react to that?
Fantastic. So, we found out, what was the issue? Huh? No. No, it was successful. So, what was the issue? It had to do with the rate of processing. I can't remember what the issue was, but it had to do with the rate of processing of specific requests in the system. And what we did was we came here and we chose pause queue, right? Fix the issue with the service and then redeployed it. I can't remember what it was right now. But it had to do with processing the messages that came in. But we simply just came in, paused it, because we were monitoring using Stackdriver. We had set up SMS and email alerts, right? So we could know when things were going on. And interestingly, where we're running our operations from, suddenly had an internet blackout. We couldn't access the internet again. So for like 2 hours, we couldn't monitor what was going on. All we had was, and on election day, there's no movement. So we couldn't move out to look for internet elsewhere. And we had multiple service providers, and they all went out. All we had left was our SMS. So we're watching and waiting and just praying no SMS came in to alert us of a problem, right? So,
Yeah. Question.
yes, please.
So when you go with the microservices architecture, your clients or the bits of the app consuming all the clients, what approach did you use in the consumption? So did you like build a middleware of some sort that was aware of all the services and brought all the services under some form of like one domain in each? You get what I'm saying? Or the client was actually aware of all the services, and how did you broker the relationship between them?
So in that particular implementation, the client was aware,
Okay.
right? A much better way would have enabled service discovery, right? So that regardless of where the microservice was, there was, like I mentioned, a middleware or something that would sort of let everyone know where everyone was without you having to manually do that. Especially if you have to migrate suddenly due to any problems or constraints. You don't want to have to do a lot of reconfiguration or pause the application in some way. So yes. So we didn't do it, but we should have done it. And we have elections coming up again in 2019 that we hope will be bigger. So we're better prepared. We're going to be better prepared. Okay. Other questions? Yes. Thank you very much.